Today we're learning about separable differential equations. So we've been solving differential equations. For example, maybe we had dy dx is equal to 3x squared plus 5. And let's say our initial condition is that f of 0 is equal to 6. And what we would do is integrate, and we'd say, well, y must be equal to x cubed plus 5x plus c. We'd substitute 6 for y and 0 for x. And our solution would be y equals x cubed plus 5x plus c. Now we're going to look at a different type of differential equation. And it's one that has each variable on both sides of the equation. So notice we've got y's and x's here, and y's and x's here. And the way we go about solving this is to separate our variables. So we can rewrite this as y dy is equal to 2x dx. Then if we integrate both sides, we'll get 1/2 y squared plus some c is equal to x squared plus another c. All right, let's combine those c's. We can do that by subtracting c1 from both sides. On the left side, we'll have 1/2 y squared. On the right side, we'll have x squared, and then we'll have c2 minus c1, which is just some other constant that I'm going to call c. And now let's say for this problem we were also given an initial condition, and that is that when x is 0, y is equal to 2. That information will help us solve for c. So we plug in 1/2 times 2 squared is equal to 0 squared plus c. So c is equal to 2, which means that one half y squared is equal to x squared plus 2 now instead of c. And we're going to continue. We're going to solve for y. We'll do that first by multiplying everything by 2, and then taking the square root. Now when we take the square root, we want to remember that there's a possibility of this either being positive or a negative. And the thing that tells us which is our solution is the initial condition. And you see, if we plug in 0, then y should turn out to be a positive 2. So if we plug in 0 here, we're going to get a positive 2. That won't happen with this case, which means that this is our solution. So let's take a look at one more example. Here's our differential equation. And notice that we've got both variables on either side. So what we'll do is separate the variables. Y is on the left, x is on the right, and we integrate both sides. Now one side will have ln of y, and the other side will have 1/2 x squared plus c. Now look what I did here. I didn't do my c1 and c2 because ultimately I know I'll combine them into one single constant. So I skipped that step, which is okay for you to do. Then we have to solve for y. So what we'll do is we will exponentiate. So we've got e to the ln of y is equal to e to the 1/2 x squared plus c. And on the left, we've got absolute value of y is equal to, we can simplify this right side. That's 1/2 x squared times e to the c. What we did is that rule of exponents, that when you multiply, you keep the base and add the exponents, so we can kind of separate them that way. And e to the c is just some constant. So what I'm going to do is I'm going to back up, and I'm going to call these my c1s, and I'm going to say that e to the c1 is my c, so that we can rewrite our solution as the absolute value of y is equal to c e to the 1/2 x squared. And without an initial condition, this is as simplified as we can get. And here is our summary. If we are solving separable differential equations, that's differential equations that have both variables on both sides, you separate the variables, you integrate both sides, you're going to solve for your constant of integration if you are given an initial condition, and your last step is to solve for y.